So in this video, we are going to learn how to solve a system of linear inequalities. Your objective is that you can graph a linear inequality, you can graph a system of linear inequalities, and then you can explain the solution to a system of linear inequalities, which is, this section should be a review of what you done last year in your 8th grade year. This is also the last section of the chapter, so you will have an upcoming test. So linear inequalities, what you need to do. You're going to graph the line just as we graphed y equals mx plus b. Remember, m is your slope, b is your y-intercept. The difference is, because it's a linear inequality, we're going to have a less than, a greater than, less than or equal to, and greater than or equal to. So the solution is not just the line, it's going to be a whole bunch of points on either side of the line. So you need to make the line either solid or dashed. The line would be solid if it's less than or equal to, or greater than or equal to. The line needs to be dashed if it's less than or greater than. And then you're going to shade one side of the line. If y is less than, so really look at the y, you are going to shade below the line. So if the line was like this, below the line would be this way. Or if the line has a positive slope, below the line would be this way. If y is greater than or y is greater than or equal to, you are going to shade above the line because you are higher. So if the line has a negative slope, above the line would be this side. The line has a negative or a positive slope, above the line would be here. And the last part of this is that you need to get y by itself before graphing, which we'll have a couple situations of that. So here's your first linear inequality you're going to graph. So again, we're going to graph just like normal. We're going to start at your b, which is 3, and move by your slope. So then while you're doing this, you need to think to yourself, do I make this line solid or dashed? Well, since it is less than and not equal to, I dash my line. You might want to do this in pencil in case you forget. And then you need to think to yourself, is y less than or greater than? Well, y is less than, so I need to shade below the line. So I like to think like this direction is going down. So I shade this side. So in this example, I have my b to be -2, and then I go up 1 over 2. And then I notice that it is greater than or equal to, so I connect my dots on this one. Arrows at the end because it keeps going. And y is greater than, so I need to shade above the line, so higher than the line. You can kind of think that this is the upper direction, or going up. So in C, on this one, what's different is that we do not have y by itself, so I need to solve for y. So first I need to move the 2x over, so I need to move the entire term, so we use adding and subtracting. So I need a minus 2x. So I have -5y is less than or equal to -2x plus 10. Then I divide by -5, and thinking about your inequalities, hopefully something's going off in your head. Oh, I divided by a negative. That means my inequality sign needs to flip. So I divide by 2, I have 2/5 x minus 2. So notice I divide everything by -5, just not the 10, because they're like, everyone gets divided by -5, and I like to do it individually. So I have -2. I go up 2 over 5. Right there. And then it is a solid line because it is equal to. And then I am shading above the line. Alright, so in D, this is another unique one, which we had this graph before when we were graphing systems of equations. This is x is greater than 5. So I don't have a y, so that just tells me all my x coordinates are 5. So my y is, we can just go pick values. I'm going to go 0, 1, 2. So I'm going to plot my points. Well, this turns out to be a vertical line, and it is dashed because it is equal to, or not equal to. I'm going to do a dashed line. And then on this, x is greater than, so I have to think to myself, what side does x get bigger? Well, that is the right side because I have 6, 7, 8 as my x values, so I shade this side. So very similarly, I have y. So I'm going to do a table. My y is -4. And then I can just pick x values. I am apologizing for the barking that's going to be in the background of this video. My dogs, which you can ask me about in class. Apparently somebody is outside my house right now. And they're very excited to see it. Alright, so graphing my line, plotting my points. I made it solid because it is equal to, y is less than, so I'm going to go below the line. Alright, systems of linear inequalities. This is putting two inequalities together. So you're going to have one, like so, and it's going to be shaded. And then you're going to have a second one that's also going to be shaded. And where the two shaded areas overlap, which is this section here, notice we kind of have 4 sections, 1, 2, 3, 4. That is going to be your solution. So we're going to go through a few examples of this. So on F, I have y is less than or equal to 2x plus 3. So I'm going to graph my first line. And I'm going to show you a little trick when doing this. I had a student show me this once, and it kind of helps you keep your two shaded areas separate. So that line is solid. Now instead of shading the side of the line that you want, what I recommend is outlining. So if you have colored pencils or markers to use this, y is less than, which is this side of the line, so I am just going to outline it in a color. What side would be shaded all the way along the line. And then I'm going to graph my second line. So that is -1. And my slope is 1. So I'm going to go up 1 over 1. Or down 1 over 1. Alright, and this line is also solid. So I want greater than, so I'm going to change my colors. We're going to do an orange. So I want greater than this line, which is this side. So I'm going to outline it. And I kind of see my two outlines where the two overlap is in between. So I'm going to shade that area right there. That is my solution. That area in between. Alright, so on G, again, I need to get y by itself. So I'm going to solve each one separately. I have -2. Again, those warning signs should go off. Oh, I divided by negative. I need to change my sign. And then the second one, I have 2x plus 3y is less than or equal to 6. I'm going to move the entire 2x over. So I have 3y is less than or equal to -2x plus 6. Divide by 3. Plus 6. I have y is less than or equal to, again, notice I divided each one individually. I divide by positive, so I don't worry about flipping my sign, plus 2. So graphing my two lines, my first one, my y-intercept is 0, because it's plus 0. Go down to over 2. Again, feel free to stop the video, and then you can kind of check answers with me. Kind of way to make sure that you're understanding what's going on. It is dashed. And then it is above the line, so I'm going to outline that in red. Alright, so in this one, it is plus 2. It's down to over 3. Alright, so on this one, y is less than. So that is this section here. So notice they overlap right here. So this is my answer. I'm going to shade it in a different color. We'll do blue. This section. Alright, so on your last example, I did skip one, just for lack of time. On this one, I'm going to graph each one. They're already ready to graph. So I'm going to go down 1 over 2. That is my slope. My y-intercept was 5. And then it's dashed. And then this one is greater than, so it's this triangle right here. And then on y is less than or equal to -1/2 minus 4, so I start at -4. And you'll notice that these two lines are parallel to each other, which kind of goes off of when we solve by graphing. These two are parallel because they have the same slope, but this one is equal to, so I have a solid line. And then this one, I'm going to do it in a different color, is less than. So what I have here is I have a shaded area here, and I have a shaded area here. The two shaded areas do not overlap, so I do not have any intersection, so that is no solution. Alright, so that is it for this video. Remember, you have solid or dash for less than or equal to or greater than or equal to, and dash is less than or greater than. Shade one side of the line. Remember, these are your belows. This is above, and y is here. Okay, and then the system where the two areas meet, and there is possible that you can get no solution if the two areas don't meet. Alright, so do your last reflection for Unit 1, so you get credit for watching this video.